Right, good morning, Year 8. So today what we're going to do is a little bit more work on fossils and look at how we get evidence from fossils, which are usually found in sedimentary rocks. So, first thing I'd like you to do is just write a definition for what is a fossil. Okay, so what actually is a fossil? So a simple thing would be a fossil is ... and what would be your sentence? Okay, so pause the video and do that now, please. Okay, so quite simply, a fossil is a living thing that died and was preserved in rock. So, a couple of things we need to actually understand. Firstly, rock layers contain many fossils, and these can show us the evidence of when the rock layer was formed. Okay, now within particularly sedimentary rock, we find fossils like this of ancient animals which are no longer alive. Okay, this one, for example, is called a trilobite. We also, though, find evidence of how life evolved. Okay, so the first task that you are going to do today is in assignments, there are these two video links. I'd like to watch the videos and then complete the dating rocks from the sheet. Okay, so here's what's going to happen. There are the videos between them about 10 minutes, and then the sheet should take you approximately another 10 minutes to do. Just bear in mind the sheet sort of repeats itself. So basically it's 2 pages, but actually they're the same page, so you only do 1 page. Okay, so the videos together are probably about, I think that's 7 or 8 minutes, and then 10 minutes to do the sheet. Okay, so pause the video and then off you go. Thank you. Okay, welcome back. So, what can we learn from studying fossils? Now, really important, fossils are generally found sedimentary rock. Obviously, they're not found in igneous rock because any fossil and bone would be destroyed by the heat of the lava. They are sometimes found in metamorphic rocks, although often they've been warped. Those would be sedimentary rocks which have been twisted and stretched, and the occasional fossil which is found in them aren't very useful. But what we can learn from studying fossils is the age of the layers of the rock contain fossils. And if we know the age of the rock, we then hopefully can work out the age of the fossil. Similarities and differences between fossils in rocks of different ages allow us to see how species evolved and changed over billions of years and what habitat was like millions of years ago. Also, show change and adaptations of species over time. So, for example, we can see here these are all species which are alive today. So a gibbon, an orangutan, chimpanzee, a gorilla, and a human. You can see all of these animals have very, very similar sort of bone structures, rib cages, arms, legs, that kind of thing. However, there are some very obvious differences. The shape of the skull, backbone, the way they're standing. And fossil evidence gives us clues as to how, say, for example, chimpanzees and humans separated from one another, and I'll sort of show you that in just a moment. However, firstly, look at this diagram. What might fossils be able to tell us about the surface of the Earth millions of years ago? So, what we've got here are our familiar places: Africa, Antarctica, Australia, India, South America. We think that the continent at one point in history, but all together. Now, there is evidence for this, not only the very obvious shape that Africa and South America seem to fit quite closely together, and that's true of other continents, but also we find similar fossils separated by what are now huge oceans. So, for example, this one, Cynoganthus, is found in South America and Africa. And the same is true of this type of plant here. Can't even read that, sorry, Glossopteris. And then for this one, Lysosaurus, that's also found in parts of South America and then South Africa. How can we explain this? Well, the tectonic plates are large pieces of the Earth's crust that move a few centimeters every year. Now, there's South America, there's Africa. Now imagine if they moved a few centimeters every year. Over millions of years, that would be thousands of miles. And that explains why we find these fossils in different parts of the world. So we can use evidence from fossils to show that areas of land that are now separate were once linked. Okay, so just in your own words, can you explain, please, why we think, using fossil evidence, the continents were once together? So, just to be clear, why do we think the continents were once together based on fossil evidence? Okay, so look at this diagram and use this to explain that. So pause the video and have a quick go at that. Just 1 or 2 sentences for that. Okay, so the most important person in discovering this idea of fossils and continental drift was a guy called Alfred Wegener, or Wagner, however you pronounce it. And what he discovered was similar fossils in different parts of the Earth, but also similar rocks in different parts of the Earth. So in assignments, there is this final video clip. I'd like to watch this. It's about 6 or 7 minutes long. And I'd like to make 5 clear bullet points about what Alfred Wegener actually discovered. Okay, so pause the video and go into assignments, watch this, and I'm looking for a spider diagram or bullet points, 5 to 6 clear points about what he discovered. Okay, pause the video and do that now, please. Okay, welcome back. So this is one of your final tasks. So what you've got here is a picture of an ancient, what we think is sort of cross between bird and dinosaur. And the fossils for this have been found. This is called Archaeopteryx. And this is what we think it might have looked like when it was alive, based on the fossils that we have. We've actually got some parts of the feathers which have been preserved. So have a look at the drawing. I want you to write down 3 adaptations that might have helped Archaeopteryx to catch its prey. How would each adaptation have helped it to catch its prey? So you need to have a close look. What are its adaptations and how it helps? Write them down. And then Archaeopteryx is now extinct. Give 2 reasons why it might have become extinct. Okay, so you're going to have to use your observations, but also why you think it became extinct. So you can just do this in your book. This is fine. Okay, so I'd pause the video and do that now, please. Okay, welcome back. So here are some of the answers. So things you should have noticed. There are teeth for biting prey, claws for gripping, and a wing, tail for flight to find prey. Such as there, you get the sharp teeth. You've always got a beak as well, which kind of reminds you of a bird. Why might it have become extinct? Okay, any reasons. So, new predators, new diseases, better competitors, a catastrophe like a volcanic eruption or a meteor, changes to the environment over geological time, prey dies out, or lack of food. Those are some of the reasons, but there is something else we forget. It kind of reminds you of a bird, maybe a bit like a turkey. The fact of the matter is, sometimes some animals evolve into others, and the fossil record gives us brilliant evidence of this. Okay, so for example, if we think of the tree of life, okay, so say for example, we've got a particular animal. I'll just actually draw this, bear with me. Okay, so the final thing I'm going to get you to do is draw a diagram like this in your book. So evolution is a bit of a thing that people don't understand. They think that, for example, fish, say quite a simple life form, quite an early life, we find very early examples of fish evolved into amphibians, which ultimately evolved into mammals, which ultimately evolved into us. Okay, they think that evolution is linear. Right, really important, it's not. Okay, this is what evolution is. Say, for example, you take your fishes from today, so just your goldfish you got at home, your amphibians, your frog you find by the pond, your other mammals, your cats, your dogs, and then humans. Right now, we are all living at the same time. So here's what happens. At one point, there was a common ancestor. There was one creature living way back in the past, or probably a whole species living way back in the past. One of them, some of them evolved this way and became on modern fish, all species of modern fish. Others maybe went on to land and became amphibians. Okay, but then these amphibians also branched and split. So some became, there was a common ancestor here, probably maybe an ancient lunged fish or something. Some became amphibians and evolved into like frogs, newts, toads, that kind of thing. But the others went this way. So then we have an ancient mammal. Some evolved into four-legged ones like cats and dogs. Others evolved into primates like us and ultimately humans. So here's the thing, we're not descended from fish. What happens is we have, if you go back down this line far enough, we share a common ancestor with fish, but one time in the far distant past, one creature went one way and eventually evolved into all the species of fish we see today, and other creatures went this way and eventually evolved into man. Now, the fossil evidence shows us how this happened, because as we go along back in time through the rocks, we find fossils which show this change and show how one species evolved from another. So we found quite a lot of these common ancestors in the fossils. We can see, right, well, this thing, for example, had backbones and rib cages, but it's not quite an amphibian, it's not quite a mammal. So we'll put that there. But if we track this line, we can see how it evolved into amphibians. If we track this line, we can see how it evolved into mammals. And here is the thing, okay? If I just quickly copy this out, the basic line over here, watch what happens. So, say for example, I draw my line, there it is, and I've got my different animals going off there like that. Okay, welcome back. So you can see here that what I've got is my tree of life. This shows how evolution happened. I've got the same basic setup over here, so it's basically the same as this. What I can do is I can add in all the animals that have ever lived, and I can see where they would go and how, for example, mammals evolved. So every red dot represents one generation, so the descendants, and in reality this would be millions and millions of generations of animals evolving from one to another, but I'm just going to do a few dots just to illustrate this. Now, here's the point that evolution tells us. If I come in like this, okay, and maybe get rid like this, science, we concede that we have not found all the fossils. Think about how rare fossils are, okay? Particularly on land, okay? You've got to have an animal die under a certain condition, be buried in mud and preserved perfectly. And of course, we haven't dug up the whole world, so we haven't found examples of all the fossils yet. But even if I remove a few of the fossils and just presume that we haven't found them yet, and we may never find them, you can still see the basic shape of this pattern, of this evolutionary tree. And so the fossil record provides really strong evidence for evolution. Science I'll definitely admit we haven't found all the fossils yet, and we may never find them, but the pattern remains quite strong. The evidence remains strong from the fossil record for evolution. Okay, even with missing fossils, we can still track how some creatures evolved into other ones. And when you think about it logically, you don't need every fossil to see the pattern. Okay? So, last thing I would like you to do today is to make sure you've just got a copy of this in your book, something quite simple, and explain how do fossils give us evidence for this. So, they show how one organism can evolve into another. Even with gaps in the fossil record, we can still see that pattern. Okay, so remember, evolution is not linear. You are not, say, descended from fish or descended from cats. No, fish and you both exist today. But if we go back into the far distant past, you share a common ancestor with fish, okay? Or your cat, or the frog down in the pond. You share a common ancestor with them. And that's the key point. Okay, so copy this into your book, please. So just to be clear about what you should have from today's lesson, you should have this diagram. You should have your answers from the Archaeopteryx questions. You should also have your sheet from the 2 videos and a very brief explanation, and your explanation of how Wagner, or Wagner, however you choose to pronounce it, how he discovered that the continents were once together, how he discovered this theory of continental drift. Okay, so those are the points that you should have. They'll all be in assignments. Good luck, and I'll be online if you need me.